Hello friends, in this video we are going to learn how if-else statement and switch case can be used in programming Arduino. I will start this video with the flow diagram of if-else statement and then by writing an example in Arduino IDE, explaining how we can use if-else statement and switch cases. Let's start with the flow diagram. The goal that I want to achieve with this flow diagram is to turn on and off three LEDs according to unique values of software timer. For that reason, I start a software timer and increment it cyclically. You will see at the end of this flow diagram how timer value increments cyclically. If the timer reaches 1 second, then the red LED gets turned on. And if the timer has any other value than 1 second, it jumps over to else if condition. If software timer is equal to 2 seconds, then the blue LED gets turned on. If the timer has any other value than 1 and 2 seconds, the software jumps over to next else if condition. Here it checks if timer is equal to 3 seconds, and if that is true, the green LED gets turned on. Only and only if timer is not equal to 1, 2 and 3 seconds, the software jumps to else case. If no condition is true, at that point software always jumps to else statement and executes its body. After executing conditional body, the software jumps back to increment the value of timer and checks first statement again, and that runs forever. Let's start a similar example in Arduino IDE that uses if-else statement and a software counter to turn on or off the LEDs. In the setup function, I'm gonna set mode of pin 8, 9 and 10 to output. We'll also set up serial communication because we'll need this later to see the status of LEDs. After setting up the configurations that we need, we can directly jump over to loop function. In this function, we can write our main function. I'm introducing the LED counter to turn on or off LEDs. Where loop function gets called, this counter gets incremented by 1. To be specific, I'm using two arithmetic operators, which are assignment operator and addition operator to raise this counter. Let's begin with if statement. If LED counter is equal to 1, then I'm going to use digital write API to set pin 8 to high. Setting this pin to high will turn on the LED connected to it. Digital write API needs two input parameters. First parameter is the pin number and second parameter is the required output state for the pin number given as first parameter. I want to print this information to serial monitor and I'm using print API to write this information. In this case, red LED is connected to pin 8. If you are not sure how serial printing in Arduino works, then stay tuned. You will get to know in one of my next videos. I want to stop the software for 500 milliseconds so that the red LED stays turned on for at least 500 milliseconds. If the first statement is not true, the software will jump over to the second statement. In a case where LED counter is equal to 2, I'm gonna use digital write API to set pin 9 to high. That will turn on the LED connected to it. I'm gonna provide this API pin 9 as its first parameter and required output state as high its second parameter. As I have done in my previous statement, I want to write this information to serial monitor. I'll use print API and write the respective information in it. Whatever we will write here will be displayed on serial monitor and we will see that once we run the software. Again, I want to put a delay of 500 milliseconds. If both of the above statements are false, then else will always be executed. In else case, I set the pin 10 to high and that will turn on the LED connected to it. In this case, it is the green LED and I am using print API to show it on serial monitor. And as I have explained before, to display our required information, we use quotation marks to start and to end our statement. To let this LED stay turned on for at least 500 milliseconds, I'm using a delay API. To turn on the LEDs again once the LEDs are turned off, the LED counter must be set to 0. In the second part of this else case, I'll turn off all three LEDs connected to pin 8, 9 and 10 by setting their output status to low. The best practice of writing software is always to add necessary information inside the code in the form of comments. I have not added many comments in this software, otherwise this video length would have been too long. To turn off the LEDs, I'm using digital write API with pin number of LEDs and required output state of LED. I'm being a bit lazy here and copying this line of code and use it for pin 9 and pin 10 to set their output state to low. All LEDs have to be turned off at least for the time that can be experienced, and I'm setting it to 500 milliseconds. Code writing is done. Now I need to compile this code. In the toolbar buttons, press verify. That will start checking the software for errors and then it will compile it. I just realized that I have not added the interface to print information on serial monitor once all LEDs are switched off. I'm adding this interface with respective information. This additional information will change the software. Compilation and error checking will be necessary after this change. To compile the software again, press the verify button. After successful compilation, we will upload this software to Arduino board. We see that the red LED is getting turned on first, then the blue LED, and then at the end the green LED. After the green LED turns on for 500 milliseconds, all LEDs get turned off. Right after 500 milliseconds, the cycle starts again with red LED. If we read serial monitor, we see that all LEDs are getting turned on and off cyclically. Let's try to achieve the same goal with switch case and see how we can use it in our software. Like the if-else example, I set the mode of pin 8, 9 and 10 to output and begin serial monitor in setup function. The loop function initializing the LED counter and increments it every time it gets called. Switch case works in a similar way like if-else statement. Switch statement take the parameter, and in our case it is the LED counter, and compare it with cases covered by it. Now we start cases in switch statement. The first case compares the LED counter with 1, and if that is true, I'm gonna use digital write API to set pin 8 to high. That will turn on the red LED connected to it. To show current status of this LED, I'm gonna use print API that will print the LED status to serial monitor. Once the LED is turned on, put a delay of 500 milliseconds. With that delay, the LED stays turned on for at least 500 milliseconds. Every case uses break command to leave switch statement. Otherwise, the software can execute other cases in switch statement and it can lead to some unexpected behavior. Let's write the second case with comparing LED counter with value 2. If that is true, then the blue LED connected to pin 9 gets turned on. Print the status to serial monitor using print API. Put the delay of 500 milliseconds here after setting the pin 9 to high and break from the switch statement. If both of the above cases are false, then the default case of switch statement gets executed. Turn on the LED connected to pin 10 by using digital write API. Provide the pin number and its required output state as input parameter to this API. Print this information to the serial monitor. Put a delay of 500 milliseconds so this LED stays turned on for at least 500 milliseconds. As I explained before, set the LED counter to 0 for the next cycle. In the next part of default case, set all three LEDs to low. Therefore, these LEDs can be turned on again with the help of LED counter. In this part of code, I am using comment. That is a good practice of remember the intention of writing those lines of code. I'm using digital write API to set pin 8, pin 9 and pin 10 output to low. Print this information to serial monitor. The purpose of calling this API is that we get informed of turning off all LEDs, and as a confirmation, we will even analyze serial monitor displayed information with LEDs. Once all LEDs are turned off, put a delay of 500 milliseconds. With this delay, LEDs remain turned off for this time because software is blocked by delay function. After everything is done, break from switch statement. Software writing is completed. Now compile the software and upload it to the Arduino board. We see that LEDs are getting turned on and off in the same pattern like in the if-else statement example. If we compare a serial monitor with LEDs, we can see that the LEDs turn on and off status is same at both places. We have learned from these two examples how we can use if-else statement and switch cases in programming Arduino. We can conclude that the if-else statement can be replaced with switch cases. The advantage of using switch case is that it has better readability. If someone is programming a complicated state machine, then switch statement would be a better option than using if-else statement. That was all I wanted to cover today. I hope you have learned something new from this video. Don't forget to like and share this video and also subscribe to my channel. Till then, take care.